go ahead and slide that under your desk. Take out your textbooks. We don't want to open them just yet because we're going to go over a few rules that we've been learning. So our first rule that I want to talk about today is exponents. And when we are multiplying exponents, what is our rule, Hannah?
You have to have the same base and an exponent.
Right, and you have to have an exponent, and if you have the same base, that's right, and you have exponents, what do you do with the exponents?
Add the exponents.
You add them. So what if we're dividing? If we're dividing and we have the same bases, what do we do then, Hannah?
Subtract.
We do subtract them. But why don't we multiply the exponents? If we had x squared times x, why wouldn't we, let's go ahead and do 3x cubed. Why wouldn't we just multiply these and get x to the 6? Because 2 times 3 is 6 and we're multiplying everything. Why don't we do that, Aloha?
Because technically that's 2 x's and 3 x's, and that does not equal 6.
That's right, it equals 5.
5.
That is exactly right, and that's what I'm looking for. Great job. So make sure we keep that in mind when we're working with our exponents. The reason we don't multiply them is because we're thinking of them if they were expanded, and that's exactly what Aloha was thinking. That's a great answer. What kind of terms can be joined together, Hannah?
Like terms.
Like terms. Give me an example of some like terms.
ABC and A squared B squared.
Okay. Do you agree with her answer, Aloha?
Not really.
Not really. What don't you agree with?
Because ABC is not the same as A squared, B squared, C squared.
That's right. Remember I said I want to be able to take what term I have and take the like term and lay it over each other and it'd be an exact copy. So you were close, you just had your exponents, so make sure even with our exponents they are different. And then lastly, we have done this before and sometimes it'll say evaluate this expression. Explain to me what evaluate means, Aloha.
It's to put in the numbers that the letters equal.
Right, I refer to it as another term, Hannah, do you remember? Maybe you don't. I like to call it substitution sometimes. We're substituting a number in. So maybe they give you an x and they say this is equal, x is equal to 2. So you know we're putting 2's in it. That's what you were getting at, Aloha. Great job. We remember our rules with our multiplying our exponents. And then we even talked about when we are dividing exponents. If we're multiplying exponents and we add them, and we know that division is kind of opposite from the operation of multiplication, what do you think we would do with those exponents, Aloha? Do you remember?
Subtract.
We do subtract them. And we're going to be using those today as we are looking at monomials instead of just exponents. Before we were just using exponents, and we had a, let's say, give me an exponent, Hannah.
B to the 4th.
B to the 4th power. So before we would have b to the 4th power divided by, we're just going to do b squared. And we talked about, can you see this, Aloha? We talked about how we need to subtract this because we know that we have the same bases and we know this means division, so we would have gotten b squared because these two cancel each other out. But what happens when we have a term, when we have a monomial? What are we going to do about that? So turn your attention over here to this one with me, and there's a few things that we want to look at and we want to check on. So what operation are we going to do in this one, Hannah?
Division.
It is division. I think we all know that this is a division sign by now, but no longer are exponents just by themselves. We now have a numerical coefficient. What is our numerical coefficient in 9x cubed, Aloha?
9.
And what is it in 3x squared, Hannah?
3.
It's 3. So you guys have a good grasp on our numerical coefficient, our literal coefficient. So we're going to use this and we're going to stack them like we normally would, or not stack them, we're going to divide them and use our division bar just like we normally would. So I'm going to go ahead and write it like this because we all recognize this, 9x cubed over 3x squared. You all realize I didn't change this problem at all. I just rewrote it in a different way with our division bar. And then I'm going to write it out in the long way. What do we know x cubed to actually represent, Hannah?
X times X times X.
x times x times x. That's right. So I'm going to go 9 times x times x times x. And once again, I haven't changed the problem at all. I'm just rewriting it. And then we know that x squared means x times x. So I'm going to go ahead and do 3x x. So it's 3 times x times x. And once again, we have not changed a single thing. It is the exact same problem. We've just expanded it. Well, we've been doing division like this since we were in elementary school, and we know we can just go through and cancel out what we have. So we know that 3 is going to go into 9 3 times. We know that we can cancel this, cancel this, cancel this, and cancel this, and this just leaves us with 1x. So we know if all of this is empty down here, it can be represented by a 1. We know there's still that understood 1 there. So this could be written as 3x over 1, and we know that the 1's not important. So our final answer on this one would be 3x. We can see that we just followed the, I see what I did. Wait, no, I had that right, because 3 goes into 9 3 times. So we're just going to follow the same process that we would with regular division. So let's look at one more, and we're going to write it out the long way before we start shortening it up a little bit. So we have 16x cubed over 4x. So again, this one is already with our fraction bar. We don't have our division symbol. It's already been put together like I did here. So we could write it 16x cubed divided by 4x, but we already know that's what it says. So let's go ahead and write this out. And just like it was over here, we know that x cubed means x times x times x. Do you agree with that, Aloha? She does. So we have 16x times x times x over 4x. Just 1x. And we're going to go through this just like we normally would. Aloha, what can happen with my 16 and 4? What do we do?
You divide it out and you cancel 4. And the 16 it goes in 4 times.
So we have 4, and then, is that what you had? Right. So we're going to go ahead and cancel that. So that would give us 4 times x times x. Well, we can put those together because x times x, how can we write that, Hannah?
X squared.
X squared. So that would give us 4x squared. And this time I left off my 1 because we know it's understood. We didn't need to bring it down like we did over here. So go ahead and look in your books at page 129 and look at number 1 with me. Excuse me. So number 1 is 4x squared over 2x. Aloha, make sure your eyes are on your book. 4x squared over 2x. Well, the first thing we want to look at is what is our operation. Hannah, what's our operation?
Division.
Division. And we know we have some exponents in there. So what else do we want to look at when we come to dividing our exponents, Aloha?
You have like bases.
Do we have the same bases?
Yes.
And we do. So we can go ahead and start canceling this one out. But with the directions, if you look at your directions, it says to write it out to represent each thing. So how are we going to write out the top one, the numerator, Hannah?
4 times x times x.
Times x times x. I think everyone would agree because x squared equals x times x. And then how do we write out the denominator, Aloha?
2x.
2x. And then we are just going to go through and cancel. So we should cancel this because 2 goes into 4 2 times. And then we can just cancel 1x, and that'll leave us 2x. So we know our final answer should be 2x. Raise your hand if you had that. You all did. Okay, go ahead and work on number 2 and number 4 at your desk, and we'll look at those in just a moment. all working very diligently at your desk. Let's go ahead and take a look at number 2. Looks like you all have finished up. So number 2, they gave us 10b over 5. And we could go ahead and write this one out, but there's really not a whole lot to write out with this one, is there? Because does our denominator have a exponent or a literal coefficient, Aloha?
No.
It doesn't. So what did you do for number 2?
I just divided 10 divided by 5 and it goes in twice, so the answer is 2b.
2b, if you had 2b, everyone nod your head. Okay, everybody had 2b. Now number 4 is also similar, except it's kind of flip-flop. We don't have a numerical coefficient in the numerator, so Hannah, what did you do for number 4?
All I can do is cancel out my y's.
And that left you with
8.
with 8. Nice and simple. Those cancel out pretty well. I like it when everything cancels out really nicely and when there's no question what your answer is. Go ahead and do number 6. Aloha, come up here and put number 6 on the board while the rest of the class, you go ahead and work on number 6 at your desk. And working on your paper. Okay, Aloha, go ahead and stay up here since that's the only one we were working on. We have a few students just finishing up. All right, looks like we're ready to go. Aloha, show us what you did for number 6. She had 24x cubed divided by 14x.
Oh,
Yeah, go
it
ahead.
was 4x.
4x, okay, go ahead.
Yeah, so 4 went into 24 6 times, so I canceled it out in 6 and 1, and then x went into x cubed once, so it was x squared that was left over, and I got 6x squared.
Great job. And we can see that she had the x and she just subtracted the 3 minus 1 and that left her with x squared. So we can still use those rules. Great job, Aloha. You can erase that and have a seat. So all the ones that we've been looking at have had roughly, go ahead and look at your book and look at questions number 1 through 6. Most of those have had how many literal coefficients, Aloha?
2 or 1 or 2.
Go ahead and look at problems 1 and 2 and tell me how many literal coefficients. We had 9x cubed divided by 9x squared. We had 4x squared over 2x. We had just had 1. So we've had just the one letter with our exponent, our one base. But what if we have a problem that looks like this? Well, here we have how many literal coefficients, Hannah?
2,
We have 2. What are they?
x and y.
X and Y. So now we have a little bit more to work with. But once again, we're going to do everything the exact same way that we would do it if we just had y over y, which we know would cancel out to be 1. So let's look at this one. And first of all, we identify the operation. Yes, Aloha?
Can I go to the bathroom?
You may. We know that we have what operation on the one I have on the board, Hannah? Division, because we have the division sign. So y'all have picked up on that. Nice and easy. So I'm going to go ahead and write this with a numerator and a denominator. And we know that 4x squared y is in our numerator over 2x squared y. So now we can look at it and see it more as a fraction, so we can be ready to go with canceling and our different things, applying our rules of exponents. But we're going to go ahead and write it out in that long form. So we have 4 times x times y. Everybody look at that and make sure I had it right, because we have x squared, so I should have 2 x's and 1 y. I think I had it spot on. So let's go ahead and do our denominator, which will also be 2x y. Now, Hannah, have I changed this? Is this a different problem than this one?
No.
It's not. And is this one a different problem from this one?
No.
It is not. Why not? What did we do? How is it still the same problem? Because it doesn't look the same.
You just wrote it out in long form.
I expanded it to show everything that was being represented. So we're going to go ahead and do what we know how to do with our fractions. So we're going to cancel, and 2 will go into 4. 2 times, Hannah, make sure your eyes are up here. We're going to cancel, both of our x's are going to cancel out, and the y's, and we have just our understood 1 down here, which is going to give us 2 over 1. And what is 2 over 1, really, Hannah?
Just 2.
Just 2. So that is our answer, 2. We have another one that has more than one literal coefficient. Let's look at 18. Now we're really going to step up our game. Go ahead and write this one down on your paper. We have 18a squared b c squared over 3a b squared c. Wow. We have a lot going on up there. Aloha, tell me how many literal coefficients do I have in that problem?
3.
We have 3, and can you tell me what they are?
A, B, C.
A, B, C. She picked them out pretty quickly. So we're going to do the same thing that we've been doing. We're just going to keep doing that process. It should become just second nature. You look at it and you immediately know I can expand it or I can cancel. So we're going to go ahead and expand it just for practice. So we would have 18a times b times c times c. Does everybody agree with me? Why do I have a times a, Aloha?
Because A squared equals A times A.
And is that the same reason I have c squared? It is. So let's go ahead and do our denominator. Hannah, how would I write that denominator?
3 times A times B times B times C.
Okay, everybody agree with Hannah? I do. That looks great. So it's nice and easy. We're just going to go through and cancel out. Like I said, I love it when we can just cancel. So we know 3 goes into 18 how many times, class?
6.
6 times. We can cancel 1a, which will leave us with our a up here. We can cancel 1b. And we're going to have this b down here. Let's not forget, because we haven't had too many where we had leftovers in the denominator. So make sure you know what canceled and what didn't. And then we can cancel 1c, and we have our c up here. So we're going to put it all together. Should give us 6ac over b. Does everyone agree with that? With our cancellations, did I leave anything off? That's what I have, and I believe I'm correct. Go ahead and do number 5 and number 18 at your desk. Hannah, you can go ahead and put number 5 on the board. Yes. Everyone looks like you are remembering the processes pretty well for our division with exponents. Right, we When you are done, you can go ahead and look up this way. Hannah, you can stay put. All right, looks like everybody has finished up. So you had number 5. Go ahead and tell us what you did, Hannah.
For number 5, I had 20 m squared n squared over 4mn. So I wrote it out, and I can see that 4 can divide into 20 5 times, so that cancels out the 4. And I can cancel out 1m and 1n to leave me with 5mn.
Nicely done. That's what I had. That looks great. You can erase that and have a seat. I'm going to do 18/4 up here at the board, and let's see if your work matched my work. So go ahead and follow along. I might just call on you to help me out. So we have 20mn squared, so I'm going to go ahead and do 20m. And how many n's am I going to have, Aloha?
2.
2 n's, so we have n squared. She's staying alert and on top of things. And then I'm going to go ahead and find 5n times n. I can cancel. 5 goes into 20 how many times, class?
4.
4. I want to hear the whole class. We can cancel. We don't have any m's to cancel, so that's unfortunate. But we can cancel both of our n's to give us a final answer of 4n. Does everybody get 4n? Your answer looks like mine. Great job. So we've looked at ones and we've been expanding them out. We've been writing n squared, n times n, b cubed, b times b times b. And I think you all have the hang of it pretty well. So what if we had this one? This is number 18. I'm sorry, this is number 3 on page 129 if you want to look on your books. It's 12a squared b divided by 3ab. Well, we can just go through and cancel. We don't have to write out 12aab over 3ab. So I'm going to go ahead and cancel here. So I would have 3 cancels into 12, or cancels out 12, because it leaves us with 4. We know these will cancel, leaving us 1a, and these will both cancel, and that gives us 4a. That took much less time, class, than it does to write it out. So if we have it like that, we can go ahead and cancel. And why do I know that a squared divided by a gives us a, Hannah?
Because that's 2 minus 1.
It's 2 minus 1. So if we remember those rules, we don't have to write it out all the way. So let's go ahead and, class, work on 6 through 9 together. 6, 7, 8, and 9 at your desk, and then we'll have a few of you up to present them in just a moment. Hannah, working on your work at your desk. Aloha, you have number 6 on the board, and Hannah, you have number 9 at the board. Go ahead and make your way. You can put your work, the rest of you at your desk. You can keep working diligently on 6 through 9. Good job at your desk. All right, we're just waiting on a few to finish up, and then we will see if our answers compare. Okay, Aloha had 6, so we did 6, 7, 8, and 9. Aloha, go ahead and show us number 6.
I had 24x cubed divided by 4x. So I did the number part first, and 4 goes into 24 6 times. And then I subtracted 1 from 3 and then got x squared. And the final answer is 6x squared.
I agree. The rest of the class agrees. Great job, Aloha. You can erase that. Have a seat. Let me go ahead and give you 7 and 8. So number 7 was a long one. It was kind of an interesting one. You just had one literal coefficient in the denominator. You had c. You should have gotten on number 7, 15a cubed b squared. I see some nodding of the heads. Looks like everybody got 15a cubed b squared. Number 8 was a simple one. We just canceled out a lot of things, and you should have had 3y. Did everybody get 3y on number 8? All right. Go ahead, Hannah, show us number 9.
For number 9, I had 25m squared n p squared over 5m n squared p. So I divided 5 into 25 to have 5 in my numerator. I could cancel an m from the denominator, cancel n from the numerator, and a p in the denominator. So my final answer was 5np in the numerator and just an n in the denominator.
Just an in the denominator. Great job. Looks good. Everybody had the same thing. You can erase that and make your way back to your seat. Everyone, go ahead and look at number 13 on your books. You should have, if your book is like mine, and I think they are, number 13, we should have 12 a squared bx over 30 ax squared. So everybody's looking at that. You can go ahead and look this way at the board since you have it in your books already. And we know that the first thing we do is look at our operation, and we know our operation is what, Aloha?
Division.
It is division. So we're going to do the same thing we've been doing the whole class long. So we need to cancel, but these aren't quite as clean of cancels as we've been having. We're used to having 3 and 9, and 3 cancels out into the 9 and give us a nice even 3. So we're going to have to look at this and go 12 and 30. So put your thinking caps on, and let's see, 12 and 30. Well, we know that 12 doesn't go into 30 evenly, so when we are trying to divide numbers that don't go evenly, what is our first thing that we try to do, Aloha?
Find the greatest common factor.
Okay, the greatest common factor. I like you pulling out those terms from long ago. And what is the greatest common factor between 12 and 30, Hannah?
6.
6, I believe that 6 is the greatest common factor. That's what I came up with. So we know that we're going to go ahead and divide 6 into each of these. So 6 goes into 12 how many times, class?
2.
And 6 goes into 30 how many times, class?
5.
5. So we should have 2/5. So that one was a little differently because we had to think about what our greatest common factor actually was. It wasn't just a nice, clean cancel. So we'll go ahead and cancel A. And if A goes into A squared, what should we have left over in the numerator, Aloha?
A.
A. Well, B, he gets to still B. He doesn't get canceled out. You like that, didn't you? And so we're going to go ahead and cancel our X. And that should give us a 1x in the denominator. So our final answer is going to be 2ab over 5x. So let's go ahead and be aware of those times when we've got to find the greatest common factor. Because we haven't really had to do that because our a's and b's, those don't have greatest common factors. We just cancel them out and subtract like we have been doing. Great job on memorizing our rules and applying them today in our dividing of monomials. So you can go ahead and put your books away, take out your homework notebooks, and write down our homework. It will be sharpening skills 19 through 28. That's all of them, not just even or odd, all of them on page 130. You're dismissed.